Hello guys! Today's lesson will be about the uniform motion. I will gonna go over all properties of uniform motion. What the uniform motion is? Uniform motion is a motion with constant velocity. Look at this car. Suppose that the car is moving to the right with constant velocity. Direction of motion is always to the right, and if you check the speedometer, you will see always a constant value. Okay? I'm gonna go over the general properties of this motion. I mean how xt graph may look like. How can I draw the vt graph? What's the relationship between them? How can I write the xt equation of motion? Let's learn it. Let's start with this toy car. Suppose that the toy car starts from this initial position x equals 2, and then the direction of motion will be to the right. And here I have a stopwatch to check the time, okay? As you see, the car is going to the right with a constant speed. As I see, in each second, the car will have a displacement of 3 meters. You see 3 meters in 1 second, 3 meters in the next 1 second, and so forth. So the velocity will be 3 meters per second to the right. How can I draw the xt graph? It's very easy. I can do it point by point. I know that xt graph must be a line because in previous video I had a detailed description about the properties of xt graph. So when the velocity is constant, xt graph must be a line. How can I draw it? It's very easy. Let's try the first point. First point, t equals 0 and x equals 2. Okay? And then t equals 1 and x equals 5. And then I continue with t equals 2 and the x equals 8. And the next point will be t equals 3 and x equals 11. And finally, the object will get x equals 14 at t equals 4. Then I connect those points. Point by point, I can draw the line. And basically, if you have more data points, they will cover more points on this line. So don't worry if you have less or more data points. As I know that the xt graph must be a line with constant slope, it must be in this format. It won't be something different. But how can I find the velocity over xt graph? You know that. It will be the gradient or slope of xt graph. Basically, for finding the slope, the best strategy is making a right triangle here, in which the hypotenuse is part of the linear graph. Here I have a rise, or the vertical side, or the height of this triangle, which is going to be 3, and the horizontal, which is the base, is 1. 3 over 1 will be 3. So the velocity of this car is 3 meters per second to the right. This is called uniform motion. Let's continue with another example. Suppose that the xt graph is given like that. You see that in this case, the graph starts from 0 with different velocity. Let's check the velocity. It's very easy. I put a triangle here and rise over run, which is, or even you can find, you can be interested to put your triangle here. Larger one, smaller one, it's not important at all. Here the rise is always 1000. Here also is 1000. If you take the same time interval, I mean from 80 to 120, you see it's 40 seconds. And here also I have again another 40 seconds. So in each 40 seconds, the displacement will be 1000, no matter if you take the triangle here or here or here. If you take a larger triangle, necessarily automatically your time interval will be larger and also the displacement will be larger. The ratio will be the same because the velocity is constant. So the ratio must be something like 1000 over 40 or whatever. This ratio will be always constant for this motion, regardless of the size of your triangle and the location of that triangle. So it's 25 meters per second. Keep in mind that as the velocity will not change, we necessarily expect average and instantaneous velocities in uniform motion are the same. It is a very important property of this motion. In general, xt graph for straight line uniform motion will be a line starting from an arbitrary point like x0, which is called the initial position, and so maybe ascending if the velocity is positive or descending if the velocity is negative. Suppose that the final time is t, and then I'm gonna find the position of the object at t, okay? Here, x. How to do that? Let's put a triangle here, okay? And remember that the slope of this graph is v, okay? And then remember the v was the rise over run. means that this is delta x over t, okay? Height over base, delta x over t. So I expect delta x to be vt, that's all. So here x is equal to x naught plus vt, finished. I did it. So the equation of motion will be x equals vt plus x naught. What the x is? X is the position, let's write it, position at time t. Okay, x naught is initial position. Okay, and what about v? V, of course, obviously it's velocity, could be negative also, not always positive, and t is time. That's all. Now let's consider different types of xt graph you may see. Here I have x naught, maybe x naught positive, 0 or negative. If the x naught is positive, the graph will start from here, somewhere above the t-axis with a positive vertical intercept. But if the velocity also is positive, the line will be ascending, something like this. If it starts from the origin with positive velocity, it starts from here, again ascending. If the x naught is negative, it will start from somewhere below the t-axis with negative vertical intercept but positive velocity. As they have all positive constant velocities, so basically the vt graph will be a line parallel to horizontal axis, the t-axis, and as the velocity is constant, it won't have any slope. Okay? Likewise, if the velocity is negative, the lines may be like this, from positive x naught descending, 0 x naught descending, or negative x naught descending. As the three green lines will have negative velocity, so the vt graph will be something like this. Again, a line parallel to the t-axis, but negative. Look at this example. The position time graph of an object is given in the figure. You see xt graph is a line starting from negative 12, so the x naught is negative and positive slope means positive velocity. Okay, also I have a very important point here, the coordinates of this point, in which the t is 5 and x is 3. And also the graph is given in SI units. Part A, write the equation of motion in SI units. Equation of motion means x equals vt plus x naught. Something I should know is the velocity and x naught. X naught is here, I know that. But about the velocity, I should find the slope, the gradient of this graph. Basically, for finding the slope, I have to establish a triangle. If I put my triangle here, the top corner of that here is a point which is unknown for me. I don't know anything about this point, so let's forget about it. If I put my triangle here, it's better, I think, because I can find the slope as I know the vertical and the horizontal sides. Vertical, here the rise is from here to here. As you see, it's from negative 12 to 3, so it's 15 meters, and the horizontal is the base, which is the delta t. Delta t is 5, so 15 over 5 is the slope. So the velocity will be 3 meters per second. Very good. So I think I can write x equals 3t minus 12. Negative 12 is the initial position. Part B, find the moment, the instant at which the object passes through the origin. What does it mean? You know that when the graph will cross the t-axis at this point, basically the x is 0, so the object is passing the origin. To find this point, as the location of the object at this point is 0, so it's very easy. I should just put x equals 0. So I plug in the x to be 0, and then I solve the equation for t. If I take the negative 12 to the left side, it will be 12 equals 3t. So t is equal to 12 over 3, which is going to be 4 seconds. So at t equals 4, the object will pass through the origin. Look at this xt graph. The position time graph of an object is given in the figure. You see, xt starts from 0, goes for 2 seconds upwards. As you see, the velocity is constant in the first 2 seconds. Then the velocity is 0. Here, as you see, between 2 and 3, there is no slope. So the velocity is 0. The last part It is also a uniform motion, but with negative velocity. So I can say it is not totally uniform motion, but partially uniform. Means that the first 2 seconds, a positive velocity, then zero velocity stops, and then negative velocity. Generally, it is not a uniform motion, but partially uniform. Draw the velocity time graph. Velocity time graph means the slope time graph, because the velocity is the slope of xt graph. What should I do here? I should check the slope here. First 2 seconds, I establish a triangle. It's very easy. Rise over run. Rise is 12 and run is 2. Height over base. 12 over 2 is 6. The velocity is 6, positive 6 in the first 2 seconds. The next part, between 2 and 3, there is no slope, you see. The velocity must be 0. So the vt graph will be a horizontal line, but exactly over the t-axis. The last part will be a motion with negative slope, negative velocity. So here again, I establish a triangle. Vertical over horizontal. Vertical is 12, horizontal is 4. So the slope will be negative 12 over 4. Pay attention. Why negative 12? Because basically the line is descending. So the slope will be negative 3 meters per second in the last 4 seconds. If you are ready, let's learn a very important point about VT graph. Look at this XT graph. It is a very easy one, you know. This is a uniform motion with a positive velocity starting from the initial position of 3 and destination is at x equals 13 in 5 seconds. When I draw the VT graph, I should just find the slope. I establish a triangle here and then rise over run. Rise is 10, 13 minus 3, and the run is 5, 10 over 5 is 2. Velocity is 2, constant, in 5 seconds. It is not something that important. You know that. But I'm gonna tell you something very, very elegant. Look at this, the VT graph. Here I have a VT graph, which is a horizontal line, and I can calculate the area under the graph, means the area confined between the graph and the horizontal axis here, this colorful part. You see it's a rectangle and the width is 2 and the length is 5, so 5 times 2 is 10. The area under the graph is 10. But pay attention, in XT graph the object starts from 3 and goes to 13. As you see, the displacement of the object also is 10, so it's very important. The area under the VT graph is going to be the displacement. Sometimes also distance, depends. What do I mean? Look at this one. This is a partially uniform motion, okay? It has positive velocity and negative velocity. In this case, pay attention. Distance and displacements are not the same. They are different because the object has a turning point. Let's check it. In the first 2 seconds, the area under the graph is a rectangle with the area of 4 times 2. So it's 8. Means that the object goes for 8 meters to the right because the velocity is positive, to the positive direction of x. Between 2 and 3, there is no displacement because the velocity is 0, and the last is this rectangular area below the t graph. Okay, it's very important. So if I find it, the width is 3 and the length is 4, so it's 12, but negative 12. So the area here is negative 12, means that the object goes back for 12 meters to the left. It's very important, negative 12. Basically, the distance is 8 plus 12, because the distance is the length of the trajectory. But the displacement, no, pay attention, displacement is from here to here. It's going to be negative 4 meters. So pay attention. When the VT graph has a part over the t-axis and another part below the t-axis, if you subtract the two parts, it's going to be the displacement. But if you add them, add the magnitudes of the two parts, it's going to be the distance traveled. It's very important. Look at this example, guys. It's very important and instructive in my opinion. Two cyclists A and B start moving at the same time. The initial position of A is 0 kilometer and her velocity is 20 kilometers per hour. So A starts from here with the positive velocity of 20 kilometers per hour. It is not SI unit. Pay attention, kilometer per hour. The initial position of B is 150 kilometers away from A. and he cycles at a velocity of negative 30. So B starts from 150, goes to the left. They will meet, Determine the time and position at which they will meet. Suppose that they meet here. What happens at that point? Basically, XA will be the same as XB because they will be at the same position, and you know that X is position. So what should I do? Here I will write the equation of motion for A and then the equation of motion for B. Then I put them equal. Then I will find the meeting time. Let's do it. The general format for position time equation will be x equals vt plus x naught in uniform motion. Okay, for A, x naught is 0 because A starts from 0 and the velocity is 20. So I write it to be 20t. Pay attention, 20 is in kilometers per hour. So the time you find will be in hours. What about the B? B starts from 150, so x naught for the B is 150 and the velocity is negative 30. So negative 30t plus 150. Then I put them equal. XA equals XB. Then I plug in the values and then I take it to the left side. So 20t plus 30t is equal to 150. So 50t is equal to 150. And so t is going to be 150 over 50. So it's 3. Basically, I expect the meeting time to be 3 hours after they start. Then I'm going to find the meeting points, the location. What should I do here? I should plug in the 3 in one of the equations. They will be the same at that time because they will meet. So XA is the same as XB. As you wish, you can put it here. 20 times 3 will be 60 kilometers. The part B is very interesting. Look at that. What is the displacement of each cyclist when they meet? Displacement is very important. It is different from position. Look at A. A starts from here and goes to the right. And as the meeting point is at x equals 60, so the displacement of A also is 60 kilometers, positive 60. What about the B is different? The meeting point is at x equals 60, but B starts from 150, goes to 60. Basically, it's negative, and moreover, it is negative 90 kilometers. It's very important. So pay attention, the displacement of B is different from A. Negative 90 kilometers. Okay, let's continue to the next part. On another occasion, the same experiment is performed, but this time B starts 1 hour after A. So B is 1 hour late. So the time of the journey for the B is going to be the time of A minus 1. As it is late, it will travel for less time, 1 hour less. It is very important. So to find when they meet, first, pay attention. We will do the same thing as before. We should write the equations of motion, but for the A, let's say it's 20t. For the B, it's going to be negative 30 TB plus 150. And what the TB is TA minus 1 because it's late. So the total time of the journey for B is 1 hour smaller, less, shorter. So I write it like that. Negative 30 times t minus 1 plus 150. Pay attention, t will be in hours, not seconds. Then I again put them equal to find the meeting point. What should I do here? I should just plug in the values. Here 20t is equal to negative 30t plus 30 plus 150. So I take it to the left side. It's going to be 50t equals 180. So the answer will be 3.6 hours. It is the time for A. For the B, the time of the journey is different. It is 3.6 minus 1. So B will travel for 2.6 hours only. Pay attention. But for finding the location of the meeting point, you can plug in the t in one of them. if you put t here, you can directly find 72 kilometers. And also, if you put the t here, as you automatically will subtract the value, basically something you put here is the time of b. Because in the parentheses, you see it's t minus 1, so it's 2.6. So you will get the same value, 72 kilometers. That's all. Again, I'm really thankful to you for being with me. Take care, review the lesson. See you in the next video.